Happy Monday, grade 9, and welcome to your Chapter 7 starting Show You Knows. So, as we go through these, there's going to be 3 Show You Knows. Make sure you just copy them down. If you need to press pause, have Mr. Dean press pause, and you can copy down the notes if you need them, or if you want, alternately, you can just watch them later on when you're home. But if Donovan, if you're actually here right now, you can't, you have to try and copy these down. Just give it a go. Here we go. So it says determine each product in 2 different ways. So we have the product, meaning multiplication of this monomial and this monomial. Now before we get into this, we got to remind 2 things. Let's go back into the chapter on exponents. And if we did this one, x cubed multiplied by x squared, we thought about x cubed as being x times x times x multiplied by x times x. And we got an answer of x to the exponent of 5 because you were multiplying x by itself 5 times. All right, so when you break down a number, you can break it down into the product of its parts. That's the first thing I wanted to remind you of. The second thing I want to remind you of is something you learned back in grade 5, and that's an area. And an area, we have a length and a width. So if this was, let's just make this distance here is 4 units, right? So 1, 2, 3, 4. 4 units wide, and we'll make this 2 units wide, so 2 units here. Oh, should I erase that first? Oh, 2 units. We would say that there are 1, 2, 3, 4, 5, 6, 7, 8 square units, 8 units squared inside there. And we got that by multiplying our 4 multiplied by our 2, right? Now that's, I know you all probably know area of a rectangle, but I'm saying that because with this particular one, we're going to solve it 2 different ways. So the first way we're going to solve it is with the area model. So if I think of, I'm going to have this little grid here, and I'm just going to use it for our x and y. So we're going to have 4 x's. So we're going to have a 1x and a 2x and a 3x, and we're going to do one more, a 4x. So our length here is 4x, and I'm going to do, I'll write it like this, and I'm going to do our width. Let's do it in a different color. Let's do it in blue, in 2y. So a y length is going to be different than an x length, so I'm going to make it a little bit shorter. All right, a little bit shorter than the x length, but still, nonetheless, it's going to represent a y value. So if I was to then connect all the dots here, all right, I shade it all in like this, and I would say, what is this tile right here? Well, this is going to be an xy tile. It's going to be an x length multiplied by a y width. And we're going to call that an xy. And it's going to be a positive xy because this is a positive x and this is a positive y, and a positive times a positive, it's a positive. So all of these are going to be known as xy's, and if we wanted to, we could shade them in, and we're going to, let's shade them in with a color here. Let's go with a nice light blue, okay? That's, shading it in is going to symbolize that they're positive. So each one of those little mini squares has a length of x and a width of y, so it's going to be xy, or x times y. And therefore, we can say that 4x multiplied by 2y will give us 8 xy tiles, okay? Or the length of 4x multiplied by the width of 2y will give us an x by y tile, or x times y. Since we don't know them, we can't actually give it a number. We're just going to call it x times y, or xy. Okay, that's the first one. Now your second one, we're going to use that same area model, and we're going to go negative x for, this time I'll just do it this way here. So negative x, so notice how I'm not going to shade it in. That's going to represent the negative x width and a positive 7x length. So I'm going to draw one of them, and I'm not going to be quite as, you don't have this luxury. I'm going to double it. Oh, let's double it, triple it, 4 of them, 5 of them. No, that's not quite 5, that's 5, 6, and finally 7 of them. So our length here of our rectangle is going to be 7. I better connect this all the way over, so 7 this way. So an x and 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 an x. So we have a width of negative x and a length of positive x. So I'm going to shade this in here. I'm just going to connect the dots together. And this time, these are all going to be negative x squareds, right? Because it's a x length and a negative x width, and an x times a negative x or a positive times a negative is going to be a negative, or more importantly, negative x squared. I'm going to make all of these negative x squared. And I'm not going to shade them in. I'm not going to shade them in because they are negative, so rather than give it a color, we're just going to leave it blank. So therefore, when I multiply a negative x, and I can use a red here, a negative x multiplied by, or 7x, the area inside will be, therefore, the area inside will be negative 7x squareds. Okay. So the first way we can determine the product is using this area model of a monomial times a monomial, and treat this as a length and this as a width, draw it out, and whatever the area is going to be the product of those two monomials. That's the first way we can do it. But the second way we can do it is even more beautiful, and it just kind of relates to, oh, that's infinite clone still, isn't it? I better take that off. It relates to our chapter kind of on exponents a little bit. So if we think about what does 4x mean? Well, it means a coefficient of 4 and a variable x. It means 4 multiplied by x, okay? And then multiplied by 2y means multiplied by, and I'll use a multiplication side, 2 times y. So we have 4 times x times 2 times y. And according to the commutative property of mathematics, the order in which you multiply numbers does not affect its products. So just to give you an example, 2 times 3 times 4 is the same thing as 4 times 2 times 3, and it's the same thing as, what else can we do? 3 times 4 times 2, which is the same thing as whatever combination you come up with. Each time you're going to get 24 as your product, regardless of how you multiply it. So because that's true, we can rearrange these multiplied parts in any order we want. So I'm going to start with the coefficients 4 times 2. I'm going to multiply those to get 8. And then I'm going to multiply the x by the y. Now, since those are variables that are not the same, I have to keep it as just x times y. So instead of saying 4 times x times 2 times y, I can say 8 times x times y, because 4 and 2 can actually be multiplied together because we know their values. But the x and the y, since we don't know, must remain variables. So 8 times x times y is the same thing as 4 times x times 2 times y. And that would be our solution, 8xy, just like we got when we did the area model. In the second example, negative x times 7 times x, it's a little bit trickier, but not a whole lot trickier. This negative x is actually a negative 1 coefficient multiplied by x, multiplied by 7 multiplied by x. So when I break it down into those parts, I'm going to multiply my coefficients first, or a negative 1 times 7, to give me negative 7. And then I'm going to multiply my x by my x. And since an x times an x, since we know about exponents, we know that x times x is going to be x to the exponent of 2, or x squared. And therefore, our solution for this one will be negative 7x squared. And if you compare your two methods that we used, both times we got the same answer, but we did it a different way. Now, obviously, given them a choice between modeling it or representing it just like this here, the product of its parts, we're going to always choose this way. And it's much easier, and that's going to be the way you default to, but you still need to be able to demonstrate on a test that you can do it both ways. Your second show you know is just a little bit different. Instead of doing the multiplication of a monomial by a monomial, we're going to do the division of a monomial by a monomial. So remember, area equals length times width, right? That's going to be our basis for this. And if I was to say, I know that the area of this one is 10 meters squared, and the length of this is 5 meters. How long is the width? You would say it's 2 meters because 5 times 2 is 10, but what you might not know is you actually maybe subconsciously use division. You took this one and you divided it by, you took the area divided by the side length you know to get the side length you didn't know, which of course is 2. So if I was to summarize that with a formula, if I was to divide both sides by, let's say, w, then area divided by the width will equal the length. Or I could say area divided by the length equals the width. It doesn't really matter. Or an even better way of saying it is simply the area of a rectangle divided by a side will equal the other side. All right, if you want to think of it, that's the basis for everything we're going to do here with modeling. So if we think about that, I'm going to first put in my side of 3y. And I'm going to put a 1y, a 2y, and a 3y. Now remember, our y's are going to be slightly shorter. And in fact, if we wanted to, we could shade them in red because we'll call those y's. We'll make the reds be y's. And the x's, we don't know yet. But we do know that inside here, this is one of the side lengths, and this here is going to represent the area. So if I think, how am I going to get 12 xy's in there? Well, if I was to draw these across and say, well, I want to get xy's. Well, there's an xy, there's an xy, and there's an xy. That's only 9 of them, isn't it? So I can extend it just a little bit further. And I have these xy tiles. Now notice they're not squares, they're rectangles, because the x is going to be a different length than the width. So we have these positive xy's here, xy, xy, xy. This is representing our area, okay? Now I know some of you are going, I'm confused. I can kind of hear Zoe right now saying, I'm kind of confused. But don't worry about it, Zoe, you'll get this. So we have 12xy. So really what this says is the area, 12xy, which is our inside, and we better shade that a color. Let's do it blue again. So that's going to be positive xy's. Okay. An area of positive 12xy divided by the side we know is going to equal the other side. So what's the other side going to be? Well, each of these are going to have to be positive x's, right? Because that's going to give us our length. So therefore, when we draw that in, we could then say an area of 12xy divided by a width of 3y is going to equal the length of 4x. So our answer for this is going to be 4x, or the area divided by one side equals the other side, so the other side has to be 4x. If we take that second question, it's going to be a little trickier. Actually, not that much trickier. It's actually easier because we don't have those dastardly y tiles. So if I take this, now the first thing I'm going to draw, I'm not going to draw my area right away. I'm going to put my negative 2x down here. So negative 1x, negative 2x. I'm not shading it in, but this is like a negative x and a negative x. So it's a negative 2 side length. And I'm going to shade in my area. Now I have to get negative 14x squared. So that means if I think about that real closely, I'm going to have to get 7 rows, 2 rows of 7. So there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7. I think that's 7. Hopefully that's 7. I think so. I'm going to cut this all the way across. And now each of these is supposed to be a square, but it's supposed to be negative x squareds. We need to have 14 negative x squareds. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, and there's 14 negative x squareds. So I know this looks really complicated, but again, if I think about this, if I drew it as a rectangle, the area is 14 negative x squareds, or negative 14x squared. The side length here is negative 2x. What is this width? If I was to have it this way, that's what it would be, right? And because we drew the area in, we could just say, okay, well, hold on, that's a negative on this. So this has to be a positive x, because a positive x times a negative x, or a positive x times a negative x, gives us that negative x squared area. So I'm going to put these in 7 times. Oh, that's short. It looks like a y, actually. But those are all x's. So therefore, the area of negative 14x squared divided by the side length of negative 2x means the other side has to be a positive 7x. Okay? And that's solving it using the area tile. So if you want to press pause here for a second and just copy it down, because I know it's a lot of stuff to write there. Okay, everyone's got that? We're good? We move on? All right, perfect. So that's using area models to determine the quotient of a monomial divided by a monomial. But if I'm going to take this, just put it up here a little bit here. If I take the other way, if I think of 12xy divided by 3y, if I think about how could I have gotten that? Well, I could think of it as being 12 times x times y divided by 3. Oh, that's a decimal. 3 times y. Or if I wanted to, I could say, well, the coefficient over the other coefficient multiplied by x over, well, there are no other x's, so I'm going to just put 1. And then multiplied by y over y. If I think about this, then if I was multiplying fractions, 12 times x times y would be. So if we think of it just from a fraction standpoint, 12 times x times y would give us 12xy. and 3 times 1 times y would give us 3y. So if I had three fractions, fraction number 1, fraction number 2, fraction number 3, and I was to multiply them together, we would multiply the numerators, which would give us this number right up here. And if we were to multiply the denominators, we would get this number here. But the reason why we want to think of it as fractions is because if this was my starting fraction, 12 over 3 would reduce down to 4 over 1, right? Or 12 over 3 would reduce down to 4 over 1. Or 12 over 3 would reduce down to 4 over 1. X over 1 can't be reduced because it's just a variable over itself. And the number y over the number y, or any number over itself, is going to reduce down to 1 over 1 regardless of what number it is. So y over y will reduce down to 1 over 1, and y over y will reduce down to 1 over 1. And now when I reimagine this as reduced monomials rather than largest terms, I would have 4 times x times 1 over 1 times 1, or simply 4x over 1, which would equal 4x. Now that's a lot of work. So if you want to press pause and just try and get that in, I'll explain it in just a second. So just press pause for a second. Okay, now obviously that's a lot of work, right? But what it's asking you is if you have your expression divided by another expression, think of it as the multiplication of its parts. Consider it as individual fractions that have like terms over like terms, and then reduce these parts, not here, but rather over here, okay? So let's see what that looks like again. So for the second question, negative 14x squared divided by negative 2x, I'm going to think, and you don't have to write this out, but, well, you do kind of, but you have to think about this. Think about negative 14 being over negative 2, multiplied by x over x, multiplied by x over 1. Because if I multiplied these numerators out, negative 14, let's take it in yellow highlighter here, negative 14 multiplied by x, multiplied by x. If I multiply those numerators, I would get negative 14x squared. And if I was to take those denominators, negative 2x and 1, and multiply them together, I would get negative 2x. So I'd get the original question I have here, right? But you're considering this and you're thinking, okay, so negative 14 over negative 2 will reduce down to 7 over 1, right? Or positive 7 over a positive 1. X over x will reduce down to 1 over 1, and the other x over 1 won't reduce down. So this would become 7 times 1 times x over 1 times 1 times 1, which is simply going to give me 7x over 1, which is just 7x, which is the answer we got when we did it with modeling, right? But what are we going to do? Oh, hang on. Okay, if you want to write that down, go ahead. I'll leave it up there. Press pause if you need to. Okay, so all we're going to say is if you had this question, you are simply going to do this. You're going to take a pen or whatever, and you go 14 over negative 2, it's going to be 7 over 1. X squared divided by x is x. That means the answer is 7x. That's what it looks like, over 1 or just 7x. So that's the work you would really show once you get really good at it. But the other stuff is used as you develop your understanding of it. And finally, question number, the show you know, calculate each quotient. So again, here we have this idea of which is exactly what we did. So it's asking just use your division of parts. So 18 over 3, if I think of that as a coefficient over a coefficient, that's going to become 6 over 1. X squared over x is just going to become x over 1. So my answer is going to be 6x over 1, or simply 6x. This next one, I probably want to rethink it as being 14y over negative 2. You can also just think of, if you thought of it just for a second, 14y divided by 2, that would be 7y, right? Because half of 14y would be 7y. That's pretty easy. Probably a grade 3 kid could figure that out. If I have 14 y's and I take half of them, how many do I have? They'd say 7y. Right, brilliant. The only difference would be, because this is negative, my answer is actually going to be negative 7y. All right? And if you want to think of it this way, 14 over negative 2 is going to be 7, or we'll put our negative symbol up there, over 1. Right? We can swap the negative symbols either place we want, and y remains by itself. So our answer is going to be negative 7y. Okay? And finally, the last one, if we can bring this over here. Ooh, not that one. Oops, Daisy, where's this go? right there, close enough. And the last one, negative 18.6 over negative 3. Here we have decimal coefficients, and that's okay, because both can be divided by 3. 18.6 divided by 3 is going to be 6.2, so that's going to give us a negative 6.2 over 1. This n over this n is going to make a 1 over 1. So when I multiply my parts, it's going to be negative 6.2 times m times 1 over 1 times 1, which is going to simply be negative 6.2 m as our solution.